Hello, everyone, and welcome to this Telit webinar, How End-to-End IoT Connectivity Enables Smart Agriculture Solutions. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating today's event. Before we start, we'd like to understand your spot in the agriculture IoT solution chain. So if you could, please take a second to fill out our poll question, which you'll see on your screen now. Now let's get to know our speakers. To explain this topic today, I'm pleased to be joined by 4 speakers. First, we have John Keever, CTO at Telit. Second, we have Adrian Clark, Customer Success Manager at Telit. Third, we have Iris Harrell, Account Executive at Amdocs. And lastly, we have Craig Watson, Head of IIoT Solutions and CI Systems Engineering Manager at RAD. Just before I hand it over to Iris to start our presentation, I have a few quick reminders for our audience. I would like to encourage you all to interact by posting questions. We will have time to answer some of these at the end of the presentation. Simply submit the question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out a replay link to all attendees at the conclusion of this webinar. And with that, Iris, I will hand it to you.
Thank you, Amanda, and hi, everyone. Thank you for joining us to the webinar today. And as you can see, this is a joint effort between Amdocs, Telit, and RAD, and we are very happy to kick it off. So to get started, we all know that the IoT currently is becoming more and more of a trendy issue. When we look at the reason why it's rising right now, if we map it, we can actually map it into 3 main reasons or 3 main catalysts. The first one is Industry 4.0 that is now pretty much a phenomenon globally that we see it across different verticals. The third catalyst is unfortunately the COVID-19 that has increased the need to have everything automated and everything being done remotely. And the third one is the need to automate, generally speaking, the day-to-day activities, and also to increase the scrutiny around cybersecurity to ensure everything is not being hacked, as you could see over the news more frequently recently. What we have done together, Telit, RAD, and Amdocs, is we are actually creating what we call a single pane of glass. It's a platform that provides an end-to-end to the provider, service provider, whether they are carriers or MSOs. So that platform would give them end-to-end solution for addressing IoT, industrial IoT, or Internet of Medical Things, or what we call the IOMT. The platform itself is built by 5 different layers: the connectivity layer, connectivity management, the device management layer, the data delivery and data collection layer, the administration and security layer, and at the top level, the application enablement platform. That's the top layer that actually allows to tailor the application to the different verticals and different use cases that we will be supporting. When we look at the platform itself, several things that needs to remember. One is that the platform provides supports to different verticals, as you can see on the screen right now. We can support the power utilities, the gas utilities, water utilities, connected industries, connected buildings and homes, smart agriculture, which is the focus of our session today, smart cities, safe cities, and e-health as well. Those verticals we can support, but we can also support horizontally, meaning if we go and deep dive into one of the different verticals, we can support each and every use case that you can see underneath each category. And I usually say that the sky is the limit, because the amount of opportunities that you can actually leverage the platform to support is enormous. You just need to be creative enough in order to leverage it to different needs. As I said, the platform can support vertical cases and also horizontal cases. So if we dive into the smart city, safe city vertical, you can see the different use cases that we're already supporting today, the fleet management, the smart parking, the smart environment, the waste management, and more and more. The platform itself can be either on-premise or on the cloud, and we are pretty much agnostic to any cloud that it would reside on. One of the key things that we definitely do is we are leveraging the partnership that Amdocs has with the different hyperscalers, such as Amazon and Microsoft Azure and Google Cloud and VMware and OpenStack and more in order to provide the service over the cloud. When we say that this is a single pane of glass, this is exactly what I mean. And you can see the different triangles that are covering right now the diagram, which I'm going to reveal in a second. But that diagram exactly shows what I meant by saying end-to-end. So if we unreveal it, you can see that the platform takes you all the way from the sensors, the cameras, the devices on the left side. It goes all the way into the IoT gateway. The IoT gateway aggregates the information and sends the data to the platform itself, where we do the connectivity management, the device management, the data collection, data delivery to create those dashboards that you can see in the upper right corner. And I also added another layer that speaks about the service assurance, which is more around the network assurance, because we would like to make sure that when we get the alerts from the system, from the platform, we get it for two good reasons. One is maybe the battery died on one of the sensors, and that's a reason to get the alert, or one of the KPI thresholds was crossed, either upper boundary or lower boundary were crossed. And that's a critical thing to receive alerts for. We definitely don't want to get alerts that are false because the network is not stable. And therefore, the network assurance or the service assurance layer was added to the platform to ensure that only the right alerts are being sent to the end user to act upon it. As you can see, we can support multiple different means of network. We can do the 4G, the 5G, LTE, we can do fiber, we can do microwave. So the platform is pretty much supporting all those options. Today, with our live environment, we're going to present the smart agriculture, which is one of the use cases that we usually present. As I said, we have more than one use case on the live environment, but the focus of today is around smart agriculture, which we're going to see a demo dedicated for that. Last but not least, the one thing I want to leave you with, those are the key takeaways, so you would take that with you and think about it later on. So the platform, again, is a single pane of glass to address IoT, industrial IoT, and Internet of Medical Things. It can handle any industry vertical, and it can be tailored to any domain. The platform supports vertical and horizontal solutions. It can be either on the prem on cloud, and it can be any cloud, and it's seamlessly integrated into any ecosystem. When I say seamlessly integrated into ecosystem, we can definitely build it into any ecosystem that you as an end user have. When we look at the ecosystem itself, it's very important to understand that the monetization or the packages will be built in the catalog within the ecosystem. The devices will be provisioned through the OSS part. The charging and the rating will be done by the BSS part. And the data itself can also be sent to what we call the data lake in order to do some analysis and act upon it as a machine learning, AI, or BI as the next best action. So I'm handing it over to you, Craig. Take it away.
Thank you, Iris. As we look at the different various devices and protocols that are being leveraged for this end-to-end solution, one of the things that becomes important is addressing and being able to choose the correct type of low-powered wide area network type of communications protocol that is going to allow us to not only extend battery life to the sensors and devices that we'll be communicating with out in the field, but also to have the range to be able to communicate to these, leveraging a single gateway that we're coming back to. As you can see, there's many different types of low-powered wide area network technologies that are available to us. Starting on the left from RFID, all the way moving to the right in Lorawan. For this specific solution, we are leveraging Lorawan as our communications platform and protocol to be able to deliver a very long-range, low-powered, as well as a very low-cost solution to communicate to these devices that are installed and put into various different places, into a farmer's field or into a hydroponic farm, or leveraged across many different areas. In order to do so, one of the important elements that you want to take into consideration as you're looking to build out your solution is identifying and finding a gateway that can really serve multiple purposes. Our SecFlow device that you see on the screen here really does offer that all-inclusive multiple interface, not only from the physical side, but on the wireless side to handle those communications. As you can see, we've won many awards last year as part of the IoT Evolution Expo. And then you'll see that we talk more about some of those different interfaces, being able to supply power over Ethernet, having LTE capabilities both on the private and public side, supporting Lorawan, serial interfaces, fiber interfaces, even PLC operations with our digital input and output connectivity, having a stateful firewall, and most importantly, edge computing. It's this edge computing that really kind of sets us apart in regards to not only having a gateway that is very ruggedized, industrialized, to handle some of the extreme temperatures where we may be installed, but also being able to have the flexibility and versatility to install some of the intelligence out at the edge to be able to address and communicate to the number of different devices and sensors that we'll be wanting to bring back and visualize within our dashboard system. The device itself, it has an embedded stateful firewall. We can actually start being able to provide intrusion prevention and detection services even down to the SCADA level. The device is a full layer 2 switch and layer 3 router and comes with other security and encryption techniques for VPN backhaul services, which really is the crux of what is important, making sure that the information that you're connecting to and bringing back into either a private cloud or a public cloud environment is very secure. Again, as you can see, we have a number of different certifications, a number of different things that we're able to supply in regards to the physical connectivity as well as the wireless connectivity on the screen. But as I said, it really comes down to being able to host many of these third-party applications, such as Telit's DeviceWise application, out at the edge to be able to consume and ingest the data from the sensors and then be able to communicate that upstream. A sample architecture that's very common with in this field is being able to look at, from the left-hand side, all the different types of sensors and nodes that we want to be able to communicate with. These nodes, make up things like humidity, soil monitoring, water metering, temperature measurement, and actually being able to have irrigation control. As we move left to right, those sensors are communicating via LoRa back into our SecFlow gateway that you see. And then we have a myriad of different types of transport options that we can then bring that information and data across a fiber communication, a public carrier LTE environment, or a private microwave instance with being able to supply point-to-point or point-to-multi-point solutions out into the field. All this is coming back up into and backhauled into a very secure aggregated IPsec concentrator, whether that's an existing organizational firewall or into our own RAD security gateway that's supplying that data and information back into the back-end application servers or analytics servers to then be ingested and consumed to go into that dashboard so that we can see end-to-end what the actual real-time status of all these different elements that we have installed into the field are actually being able to be displayed, and important decisions are able to be made based on some of that information. So again, having a complete end-to-end solution is very important as we look at being able to take these solutions in a very comprehensive manner and be able to easily supply them into the environments that we're working today within smart agriculture. With that, I'm actually going to turn it over to John Keever, who's going to walk us through a demo of the actual solution and show us what this looks like. John, take it away.
Okay, thanks. I'm going to pick up here and I'll go into a live demonstration showing the platform, showing the application concept for smart agriculture and how we can deploy the platform and the various components to address that particular solution set. So I'm going to go ahead and log into the platform. And here you see is kind of a dashboard overview of what more of a management person would see in the context of the system. It gives you a quick overview of your connections, what's connected, what's the health of the connection, what type of APIs are being used, and what systems have been connecting in. Due to the fact that the platform is a multi-tenant environment, I have the capability to change between different tenants and environments in the system. Here you can see very focused on the demonstration platforms for Amdocs. You can see everything from different e-health solutions, smart ag, et cetera, and the different APIs. Right now, all of our devices are connected. We have good connection health, and we have a very uniform use of APIs in the system. For the demonstration today, what I'm going to take advantage of is using some of our tools from a management portal perspective. Here you can see the things, or what we call the thing viewer, to actually go in and look at what's going on within that particular solution, and how that's working. Today, the solution for Smart Ag is as a collection of a gateway that's at the site, and then that information is then being published from sensors over LoRa, and then backhauled through the gateway into the network upstream, whether that's backhauled on a wired network or a cellular network as need be. So the actual RAD SecFlow gateway is the key gateway part of the system, and here you see that it last reported in 34 seconds ago, and the type of information that's going to be presented in the platform is going to be very specific to this device. Okay, CPU usage, memory usage, the types of things you would see at a gateway level, and of course the different types of things you may want to do with the gateway. You might be able to take action on specific endpoints to allow things to work, deny things to move data. In this particular situation, you have LoRa sensors that are bound through this gateway to communicate data upstream into the solution set, as well as the ability to tunnel into that gateway and remotely, work with that gateway to take action on the particular solution set. So we have that type of activity going on within the network, but also we have the sensors themselves. So we can go take a look at any one of these specific endpoint sensors and see that the specific data for those sensors, things like the frequency that they're communicating at, their signal, level, signal to noise ratio, things of that nature are being recorded, as well as the actual live data that we're interested in, from the sensors, the humidity, the light, the moisture level, ambient temperature. Typical agribusiness type of solution set for these. You'll also see there's associated alarm state with each one of these. Are we in a good moisture level for this particular sensor area, or are we in some kind of drought or dry alarm, or are we in some type of flooded or moist alarm, depending on what the different states may be for those particular sensors. So we've got those types of things to deal with. And what I'm going to do is actually go into some of the dashboards that would be used by an agribusiness professional, in the context of the solution set. So we'll go and take a look at what the agribusiness professional would use. Smart agriculture is basically the technology of applying key indicators and measurements, basic attributes and parameters to a specific field status or livestock status, or what you might be working, to address within your solution set. So in this particular area, you might be looking at an area of the field and whether it's in need of irrigation or not, because we're going to be focusing on from a standpoint of smart agriculture today, the context of irrigation and the ability to automate that and to gain better control over your agricultural solution. But many other solutions exist in the agribusiness domain that could be addressed by the Amdocs solution as well. It could be livestock management and monitoring. It could be more advanced crop management, where you may have sensors that go down into the soil and look at nutrients and things of that nature. It might be, at the germination phase, or within greenhouses, where you're first getting the crop started, or something as advanced as autonomous equipment operations, where you're starting to monitor the equipment, not only the different attachments that are used in the equipment themselves, but where they are, how they're scheduled, and things of that nature as we move more and more into precision agriculture. And here we have other applications within agribusiness where you might be looking at feed monitoring and management, where you even have solar cells in the middle of the field to power the the gateway and the processor and the sensors to then be able to note and transfer, turn on pumps, open valves, etc., to make sure that feed and water are available, or that same technology applied within the actual barns and feed facilities themselves, where you'd be monitoring livestock into and out of that, as well as making sure feed's available at certain times of day, to balance what's needed in terms of the actual production, and up through, as I referenced before, precision farming, where we're getting more and more intelligent at the field level and the equipment level, where they're becoming more unified in their day-to-day operations. And then, of course, the application all the way up through autonomous equipment, where you might be working on a 24/7 type of basis. Here in South Florida, we actually have a lot of sugarcane production, and when it becomes harvest time, you're going around the clock to do that, and the ability to monitor the equipment, to monitor where the equipment is, the status of the equipment, to minimize any type of downtime against getting those fields, in for processing and delivery. So what we're going to be working on today is to take and expand, that story and kind of explain what's going on. For our solution scenario, what we're going to do is have some endpoint sensors. Those LoRa sensors that are referred to earlier have been configured to look at the ambient light, the humidity within the air, the moisture within the soil, and then the ambient temperature. So 4 key parameters that are very critical in agricultural type solutions. That information is coming in over LoRa into the RAD gateway to then receive that information, process it, and then communicate it, upstream or into the cloud platform, which could be done over LTE infrastructure, 5G infrastructure, or wired, whatever the solution scenario needs to be for that particular farm implementation. And then the IoT platform would collect that information, persist it, but also make it available for dashboarding and logic in applications within the solution set itself. So what we're going to do is we're going to go through and we're going to process some live data, look at some of the screens that the agribusiness professional would use, and go a little bit deeper in how the solution could be deployed. So I'm going to select live data here. And what this takes us into is kind of an overview display that would typically be, seen in the context of the agribusiness professional. It might be on his tablet, his smartphone, maybe a web browser, where he wants to be able to go, or they want to be able to go and look into an area of the field. Here we had 4 different sensors. That could be, 4 different areas of the farm. And then you can drill down and say, okay, for this specific field area, what's my, humidity level looking at, what's my moisture level in the field looking at, do we have adequate sunlight, how does this then affect, because obviously in a big data solution, all of this type of information could be taken and then correlated to other dynamics. How was their field production this year, from a standpoint of yield and things of that nature. Other information is also presented here. We have our device list where you can actually select directly into the different areas of the field or the different sensors that are associated to it. You also have, the capability to allow and deny the sensor activity, and that's more in the context of an area of the field, maybe, either in crop rotation, or it may be, in cultivation or something of that nature, or you may be actually changing irrigation equipment, and you want to ignore, false signals coming into the system. So you have the ability to effectively ignore the data and move those devices back and forth, and I can demonstrate that as well. In this particular scenario, you see the endpoint ID, you see that it's currently in a connected status, but you also have the ability at your fingertips to move the different devices devices into or out of an active state. Now, to get the demo started, what I'm going to do is actually take one of these domains, and we're going to do something a little different than normal. We're actually going to go in and force it into a low moisture condition here. So we're going to go to a little lower level menu. Here is a menu showing much more of the sensory level information, signal to noise, signal strength, things of that operation or that nature. But what I'm going to do is actually, instead of turning the irrigation system on or off, I'm actually going to tell it that for this particular sensor domain, the 340 domain, we're going to go into a low moisture state. So what we've done is effectively, kind of force that condition into the system. If we go back over to our, to our actual thing viewer and take a look at the different alarms, you'll see that currently that area of the field is in a low or dry condition. And if we go back over to the actual agribusiness screen and take a look at that particular, area of the field, we'll see that indeed our moisture level has fallen to less than 20%. Our humidity level is low. You can see the drop here, as far as, our data going along at 30-some%, and then falling, drastically down to 28%, same being true for the moisture level. So now we're in a dry condition, and due to the fact that the system would normally in an automated deployment then cause irrigation to kick in, you'd crank up the irrigation pumps and start the irrigation process. What we're doing for the context of this demonstration is simply doing some alerting here to take advantage of alerting. So, what I should be seeing here as we go through the system is alerts coming in and being processed so that we know when we have, different temperature changes, alarm changes of that nature. So, we'll be, looking to see that as we move on through our demonstration. But right now we're in a low moisture state. And once we get, past the low moisture state here, then what we will do is, take action on it. Since we have a notification, we can, act on that. So what I'll do is go back to our control environment. We'll pick that sensor area again. And now what we'll do is actually take action to enable the the irrigation. So when we do that, effectively what we're telling the system is, okay, now start up the irrigation pump. Start the irrigation in that particular sensor area where it's been identified as being in a low moisture condition, and then let that start running. And you see here, even at the lower level, you see some of the signals changing. The moisture in the air is going up because obviously the irrigation pumps have turned on, so there's water in the air, humidity and everything, going along that nature. So let me go back over and pick that. So if we go back and pick that area in the field, you can see that it's changed significantly. We have a very, high humidity level just due to the fact that the, water in the air from the irrigation sprinklers affecting the signal coming in. But in parallel to that, obviously the moisture in the soil is rising and going up as well, so that you're providing the actual irrigation that's needed, along the way to do that. So let me go check on our notifications here and see what we're getting. I'm just going to refresh that screen over there. One moment here. Let me see if I can pull in what is going on here. Let's see, we'll go in and sort on device-wise. Okay. So I've got some alert notifications here. Let's see, smart notifications set, low soil moisture. There's a low soil moisture notification. Right now we've got a high soil moisture notification as the as the actual, signal is coming in as well. So what we can do is then, it's basically saying, from the system automatically, you've got a high situation located in this particular area of your field. You may want to take action, if your pump is running. So basically, we know that we probably need to take action and stop the actual irrigation process so that we can get that back under control. So what we'll do is take advantage of, given the fact that we see the data, we'll go back out and in this scenario manually control the irrigation. Again, in a normal deployment, this would be done automatically, of course, but for the purpose of the demonstration, we'll control it ourselves. So what we effectively just did was send a command out to the actual irrigation pumps associated with that endpoint sensor, and we can see that we've already caused an adjustment in the moisture and the relative humidity, things, coming back down and under control. If we go back out and take a look at the system, go look at that specific sensor area, we can see that things are back, under control. Our current moisture level is around 6% in the field. Our humidity level is back in the low 40s. Ambient temperature and luminosity, are there as well for the time of day that that we're showing. So that basically showed a basic overview of the operations, getting the live signals from the sensory level, controlling the moisture and such by way of actuating the irrigation pump system. What we can also do is show how devices could be taken, offline in the event that you want to ignore the data. So let's say that we wanted to take, this 342 sensor offline, the ability to move that, into an offline state is as simple as, again, a few finger clicks on your tablet, moving that over to the deny list, for the purpose of to kind of moving things forward. I'll go ahead and force a refresh on the screen, but you can see that now that device is no longer selectable in the device list. It's been moved to the deny list, so that it's no longer, available for operations. In a similar manner, we could actually go and default, a device if we wanted to, just to show a lower level recovery. So let's go ahead and do that. Let's take the 344 device, and we can work with that particular device here. So what I'll do is put this device into a fault state, and the system lets us know that it's now, obviously, in the real world, this is the last thing you'd want to be happening. You'd want to be able to reply to a fault. So if you see a fault status, to be able to reply to that. And in our situation, what we've done here, at the actual, system level with live data, is that we have gone through and we'll pick an actual one of these. We can see that right now this 344 is no longer connected, so we have an issue there. We see that this 342 unit is not being processed. So from a standpoint of operations, we have some issues here that we probably want to react to. If we were to go in and look at the 344, we would be, alerted that it's in a disconnected state. So data's, not coming in here. So that needs to be addressed. We can't even access the 342. But what we could do is to move that back to the 342, move that back to an online state so that it can be processed. So what we've done is made the request to move that out of the deny list back into the allow list so that it's acceptable on the device list. So if we go through and update the screen, we should see that the system has done that. It's moved the 342 system sensor back online. That data is available. Now we've still got this other sensor 344 in fault at this point in time. It's no longer connected, so we need to take action on that. Now, to address that, in our solution scenario here, what I'm going to do is actually, reach out using the actual gateway and reach out to that endpoint sensor, where we have the physical gateway here connected, to the sensors. And if we take a look at the actual, sensors that are available and take a look in the sensor list here, what we see is that 344 sensor is in fact in fault. And this is where the edge processing is being done. This is where the data is being processed and whatnot. And so this is where the edge logic of the system, executes. So that from a standpoint of how that's put together within device-wise, you can see that, logic is applied at the edge so that as data comes in from the sensors, it can be processed in different ways in different states. And that's really a topic for a later conversation, but it basically gives you a little bit of context of the fact that the solution takes advantage of edge intelligence intelligence as well as platform intelligence. To get this particular sensor back online, I'm actually going to take advantage of the gateway here, and we'll change that state back to get it out of a fault state, and change that state here at the edge. And so what just happened at the edge is we communicated back downstream to that particular edge sensor, the 344 edge sensor, to basically perform a reset. And then as a result of that, sensor performing the reset, then you'll see this just flashed yellow. If we refresh our screen, you'll see that now the sensor is back online. It's in an active state. It's cleared from a fault state. And similarly, if we go over and refresh our mail here as well, let's go ahead and pull that up, then you should see that we've had notifications come in for low and high moisture. I don't see the actual fault. I was going to actually refresh that. I want to make sure I'm on the right panel here though before I do that. So let's see if I can bring that up here. If it'll refresh when I do a search here or anything of that nature. Okay, high soil moisture, we see that. So we need to go see if we're getting an alert notification here today. So no, that got started. But the ability to see when we have notifications, the fault notifications and all cleared are part of the overall solution as well. So there, all of our sensors are online. Now this sensor, the 344, shows that it's once again connected. If we watch, as data changes, then we should see, live data coming into the sensor for this particular area of the fields and being processed as well. So it basically shows how the system can be managed at an edge level as well as at the platform level. So that if we move back out to an overview of all the different field areas, we see different things that the gateway reported in 26 seconds ago, that each of our sensors just reported in 13 seconds ago, but all of our states for the field are in a good operational state. So that's pretty much an overview of what I wanted to show today for the demonstration. The ability to actually to go through and show smart agriculture from a standpoint of the metrics and how the combination of the LoRa sensors with the RAD gateway and the Telit support for the device-wise at the edge and the Amdocs implementation of the portal can be used together to address smart agriculture to solve your particular problems. And obviously there are many other agribusiness type of solutions that this could be provided for as well. Hopefully it's been informational. It's been a pleasure demonstrating it. Thank you very much.
Thanks, John, for that great demonstration. I'm now going to pass it to Adrian to wrap us up here before we open up the Q&A to our audience. So Adrian, please take us away.
Thank you, Amanda. So I'm going to take you through the summary of the value proposition of what you just saw. So the platform is not just for smart ag. It can really be used in any domain or vertical, such as Industry 4.0, smart cities, and much, much more. This is a highly secure, open, and agnostic platform that can be hosted in your own private or public cloud or on-premises. And it can be seamlessly integrated into your existing ecosystem, enabling you to focus your efforts on building your applications and not your infrastructure. So our tool set helps you to quickly and easily connect your devices and your enterprise systems together, providing you a faster time to market. And as Iris said earlier, the sky really is the limit. And with that, back to you, Amanda.
Yep, thanks, Adrian. Before we get to the questions, I am going to drop one last poll here for our audience. If you'd like to have one of our experts contact you directly, please respond here on the poll and someone will reach out. We do have time for questions now. I see quite a few that have come in already. There is still time to ask a question, so please go ahead and submit using the box to the right of the slide presentation, and we will do our best to cover it in the time we have left here. And I am going to just go ahead and dive right in. First question we got here was, can the platform be branded as needed?
Okay, so let me take that. Thank you, Amanda. So the short answer is yes. The platforms can be branded or skinned in any way we want, and it can be tailored to any service provider as needed.
Great, thanks. Next question here, and this one might be for you, John. Is most of the data processing performed at the edge in the gateway or in the cloud platform?
Sure, Amanda, I'll be glad to handle that one. In the scenario that we presented today that you just saw in the demo, we were using LoRa at the edge with the gateway there to support the LoRa protocol to handle the packet serving and the communications interfaces there. So it was very critical, at the edge to handle that data, reduce that data, format that data, and then move the information up in the cloud platform. But the cloud platform also played an active role as well, using logic and capabilities of the cloud platform to do the notifications and the call out, as well as some of the formatting for data to be presented in the dashboards. It really depends on the specific solution that we're addressing as to where the processing goes. The nice thing is the architecture is flexible enough to allow you to focus at the edge or to move to the cloud, and really in an ideal situation, let the processing be performed where it's most effective. Take advantage of both the cloud and the edge.
Great, thanks, John. Next question we have here, what security enhancements have been made to the RAD product to ensure endpoint trust?
I can take that one for you there. So a lot of things around the security enablement not only have to do with the Lorawan protocol itself and being able to properly authenticate and identify the devices and sensors that are we're communicating with and actually talking to, as you kind of saw in the demo, but also being able to handle things like CERT-based IPsec encryption to identify and be able to trust the gateway that's being deployed out there in the edge, as well as integrating that into a PKI infrastructure to leverage certificates as well as certificate authorities with Microsoft SCEP servers. So there's a number of different components that can really be able to lock down in order to be able to trust and verify some of those devices, sensors, and information that are being deployed out into the field, as well as what we're being able to see within the dashboard system. So multiple things at our disposal to really kind of lock down the environment.
Great, thanks, Craig. Next question we have here, is Telit supplying the end-to-end solution, or is this being done by several partners in the ecosystem?
So I can take that and then I'll hand it over to John. Basically, the end-to-end solution is provided by the overarching Amdocs ecosystem, and we are leveraging the Telit platform as part of that, but the integration itself into the BSS OSS ecosystem will be done by Amdocs in order to tailor it into the existing ecosystem for a seamless and smoothless operation. John, if you want to add a little bit on that.
Oh, absolutely, Iris. I mean, in addition to that, I mean, clearly in the domains that you may be, addressing, within the, smart ag, smart cities, smart home, whatever, obviously, typically Telit works with partners that are, focused in those domains to bring their special, capabilities and knowledge to use the tool set. So it would be a joint effort, depending really upon the specific solution set. How we would work together. The main thing would be to make sure that, what we delivered met the requirements and provided the value that was needed.
Thanks, guys. Next question we have, are the alerting capabilities built into the IoT platform?
This is Adrian. I can take that one. So the alerting capabilities are built into the platform via a feature called Cloud Triggers, and you can consider it to be like an event-based rules engine. So we can do alerting and much, much more based on data that is published to the platform on behalf of the devices. So we can monitor thresholds and then send an email alert or an SMS alert. And not just that, but we can also deliver it to HTTP endpoints and other third-party systems.
Great, thanks, Adrian. This one might be a bit further to that as well. What IoT platform do you run on? Is this IoT Azure?
So I can take a stab on this one. It's Iris. Basically, the point is to allow the platform to run on any cloud, and we will be leveraging the relationship and partnership that Amdocs already has with all the hyperscalers. So we have partnership today with Azure, Microsoft Azure, with Google Cloud, with Amazon, with OpenStack, with VMware. So basically, we would be leveraging that to run the platform on any cloud that is needed.
Great, thank you. Next question that we got. In the context of SmartX, what other sensor and actuator interfaces are supported in addition to LoRa?
Amanda, I can take that. We were focused here today on Smart Ag. We're looking at using LoRa, but clearly, even in the context of Smart Ag, there's many other protocols, wired and wireless, that maybe need to be supported in the context of sensing. It could, be Bluetooth, based interfaces. There could be, even, NB-IoT and kind of low power, cellular that would play a part. But then there could also be numerous wired interfaces as well, where you're talking specifically to controls and actuators to work within the feed locations and work within the processing locations. All of these types of protocols, whether it might be logic controllers, material handling equipment, or even telematics within machinery as well for autonomous control, or all the types of things that we support at the endpoint. We often refer to it as either the first mile or the last mile of IoT. It's making that edge connection that many times can be the most challenging, and Telit and our partners have many years of addressing that kind of integration.
Great, thanks, John. We got a few more questions here. Is your solution portfolio available in Latin America or just Europe? Can you talk through that a little bit?
Yes, so the solution is available everywhere, and there is no limit to a specific continent or a specific country. So it's available everywhere. And we're actually actively talking to customers in other regions other than North America.
Thank you, Iris. Let's see, next question we have here. How frequently are the devices sampling? How often do they upload, and what size battery do you use?
I'll take that. Craig could as well, but it really depends on the sensors and the batteries. I think in these situations, we're working, with devices, here that, for the process of the demo, we had a very simulated environment. So we were actually, effectively, providing live data in near real time at, 15-second thresholds. Within the actual field deployments, usually you would be, based upon a collection of, long life batteries that would be, providing the energy source for that. Would typically be sampling, with hopefully a lifetime of, 3 to 5 years. This field sensors with sampling anywhere, in the 5 to 15 minute range. It just really depends on how often that data is needed. For the smart ag scenario in this particular domain, clearly it's often enough to be able to take action and handle the smart irrigation that we were addressing. So what we were providing in the context of the demo was greatly accelerated in terms of a time, domain. But for real live domains, real live implementations, you're typically, talking, something, in that, 5 to 10 minute, 15 minute time frame to extend your battery life.
Yeah, and I think to your point, John, this is all customizable. So really kind of depending upon how often you're wanting to get some of that real-time information and status, you can set that up and be able to leverage the infrastructure to communicate to those sensors. But to your point, the more often that we are talking to these Lorawan sensors that are battery operated, it does kind of lower their life expectancy out in the field, and we might have to go out and change them out just depending upon how frequently we are talking to them.
Great, thanks guys. We've got just a couple more questions here. And Iris, this one may be for you. What are the options to support analytics? Okay,
great question. So usually when we speak about the analytics, we usually leverage two of the Amdocs product. One is Intelligence One, and the other one is called Data One. We also have PR of production use cases that we have done with both of them. And one of them at least is with a hyperscaler. So that can be shared offline, but those are the key things that we would usually recommend.
Great, thank you. Next question I've got. You mentioned LoRa. Are you LoRaWAN standard? And if so, if I have other LoRaWAN devices to add to the platform, say something like door sensors, can I add them and how would I do that?
I can take that, Craig, if you want to add, you're welcome to as well, because we both work at the edge. But clearly, the LoRa protocol is very well defined in terms of, the packet header and the payload. Obviously, the main differential between any one of those endpoint LoRa devices is going to be the payload and how to decrypt or how to send a configuration packet down if it's a Class A LoRa device to be able to configure the edge device. But the capabilities within the device-wise, gateway at the edge allows you to, very simply using the flow format that I showed during the demonstration to allow you to basically, parse and process that payload to extract your data elements out of it. So it really comes down to simply provisioning the sensor, into the network, identifying the sensor type so that it gets matched to the proper parsing mechanism, and then that data is made available in the system, whether it's being published upstream or acted upon locally. That would be up to the specific application requirement.
Yeah, and the fact that we are following the LoRaWAN standard does allow us to communicate to other LoRaWAN specific devices and sensors, such as door alarms. All of those can be communicated with, as well as brought up into and ingested within the back-end system to be visualized, so that you can actually see not only, again, some of the things that we showed in regards to humidity, temperature, saturation levels, but also if you wanted to have a different module set there to trigger a door alarm, maybe on a control house or a gate area, that can all be communicated and brought through and seen visually within that head-end dashboard as well.
Great, thanks guys. Another question here on LoRa. What other verticals is LoRa a recommended technology for? Maybe Adrian, you want to grab this one?
Yeah, it might be Craig also, but LoRa is a great technology to be used in a lot of different solutions, but primarily I've seen it used in smart ag, smart meter, and a lot of smart lighting and smart parking. But Craig probably has a lot more use cases than that.
Oh, sure. Yeah, we're seeing this, being leveraged across smart buildings. Again, that the door alarms, being able to supply remote management and monitoring for remote locations, being able to supply different types of LoRa sensors to be able to communicate that information back, really kind of goes across all the different verticals and use cases that we've discussed and relayed already. So again, whether that's within power utilities, oil and gas, water, we're seeing a lot of interest within the industry and Industry 4.0, plant manufacturing, the smart city efforts in regards to being able to even identify some of the items like if there's ice on a sidewalk and being able to deploy crews to go and handle that, to some of the smart parking items that Adrienne addressed, as well as again being able to really kind of cover all of the various different verticals and use cases that were talked about earlier. So LoRa does have that ability to be able to be addressed and utilized in multiple different industries and in multiple different facets.
Great, thanks, Craig. I think we've got time for one more question here. So last one, what is the solution if we have no cell signal?
So I want to take that one. I think that one of the key solutions that is emerging now into the industry is the use of satellite communication. And especially in rural and sub-rural areas where you don't have the cell connectivity, you don't have any intention to roll out 5G, which is quite expensive. One of the key solutions is to start leveraging the new technology of the LEO satellites, the low Earth orbit, in order to gain the communication and also use it for the IoT devices. That would be the most efficient way to do that. And again, Amdocs can support those value propositions as well. But I think that would be the best way to solve this case of no connectivity in rural and sub-rural areas.
Great, thank you. We are coming up on the hour, so I believe that is all the time that we have for today. Please be sure to check your inboxes in the coming days, and we will send out this replay link. Again, thank you to all of our speakers today, and thank you to all who joined.